While electrical systems are generally not associated with spacecraft, rockets do have computers, communications equipment, telemetry, reaction wheels, control moment gyroscopes, lights, radar, and many other systems that require electricity. Many spacecraft generate electricity in addition to storing it in batteries. One way they do that is with photovoltaic panels. Photovoltaic panels, or solar panels as they are more commonly referred to, can generate electricity from sunlight. They do that using two different layers of silicon. One layer is N-type, or negative, while the other is P-type, or positive. N-type silicon has extra electrons, which makes it negatively charged, while P-type has extra protons, which makes it positively charged. When the protons in sunlight hit a solar panel, they dislodge several electrons, which then try to move into the positively charged part of the solar panel. But the only way to enter the positive side is through a wire. The movement of electrons is electricity, and the movement of electrons in the wire can run electrical systems. Solar panels are great because they have no moving parts, so they can last for a very long time. But they are not always the best choice for rockets. For example, missions that go far out past Earth would not use solar panels because there's not enough sunlight to run them. Long-term Mars rovers missions would also not want to use solar panels because the dust on Mars could cover them and make them fail. Finally, craft that want to generate electricity while moving quickly through an atmosphere would also not use solar panels because the aero forces would make the panels snap off. But outside of these situations, solar panels are great at generating power. Another device that generates electricity is an RTG. RTGs are radioisotope thermoelectric generators. They take a radioactive isotope and let it decay. While it decays, it releases heat. The heat is then converted into electricity using a thermocouple. In a thermocouple, electricity is generated using the Seebeck effect. The Seebeck effect says that when a metal is heated up, its electrons will move faster and will generate a negative charge. The electrons in the hot end will then move to the colder end, and because electricity is the transfer of electrons between atoms, this generates electricity. RTGs are a great way of providing power because they are small, have long lifespans, and can be internal components. This makes it so that they can last a really long time, and they are easy to incorporate into the spacecraft. The problem with them is that they produce nuclear radiation, so it cannot be used in crewed spacecraft. Spacecraft can also use fuel cells to generate electricity. The space shuttle used a hydrogen and LOX fuel cell. In the fuel cell, the oxygen is run over a cathode and water. The LOX reacts with the water to produce hydroxyl. The electrons from the cathode then are added to the hydroxyl so that it can produce a hydroxyl ion. The hydroxyl ion is then sent over to the hydrogen side, where it reacts with the hydrogen to produce water, electrons, and heat. The spare electrons are collected by the anode and are used as the electricity. Fuel cells are great because they can be used on crewed vessels in the atmosphere, but outside of those circumstances they are not used often. If a spacecraft generates too much power, then they have to store it. The storage is done in lithium-ion batteries. These work on the principle of valence electrons. Valence electrons are the number of electrons in the outermost layers of an atom. Atoms always want to have a full set of valence electrons, and they will either lose or gain electrons to do so. Lithium atoms have one valence electron and will always try to lose it. But the lithium is still not stable until it is part of a metal oxide. So in a lithium-ion battery, you have a lithium ion, a metal oxide, and an electron. The ion and the electron will move and join with the metal oxide. The electron moving is electricity. But the batteries aren't that simple. Also in the batteries are aluminum, copper, graphite, and an electrolyte. When electricity is put into the battery, one side of it becomes negatively charged. This makes the positively charged lithium ions move towards it, but the electrons don't move because they are trapped in the graphite. When all of the lithium ions move over to the graphite side, the battery is fully charged. After that, an object that uses electricity can be connected. The lithium ions will migrate through the electrolyte back into their stable state with the metal oxide. Because the lithium ions are missing electrons, this will make a positive charge on that side. This will attract the electrons over to that side, but they can't move through the electrolyte. This means that the only way they can travel is through the entity that requires power. Afterwards, a power source can be hooked up again and will generate an electric charge on the graphite side so that the electrons and lithium ions return. This is a very effective method for storing electricity so that it can be used later.